So we're going to start off with our...
It requires a password once more.
Share. Is it working?
Yeah.
Yes.
Okay, so we're going to start off with our first chapter, which is to do with sequences. So this all comes under the number topic. This is going to be one of those days. It's like, why is nothing working today? Document. Okay, so sequences, and today is the 10th. All right, so last year you did two different types of sequence. Can you remember what types of sequence they were? You looked at? Mr. Potts, you might have given you the names of them. First one was arithmetic. Have you heard of that? Yeah. So there's arithmetic sequences. There's other sequences. Did he talk about geometric sequences? Yeah, you think so? Okay, well, we're going to be going over this again, okay? And those are the two main sequences that we're going to look at. But the first thing that we're going to do is to do with notation, okay? And we're going to look at something called sigma notation. I take it you all remember what a sequence is.
Yeah.
Yep. What is a sequence?
It is a series of numbers that are ordered in some sort of way, you know.
Yeah, no, I'm going to be a bit picky here. You said a series of numbers. Series is actually something slightly different, okay? A sequence is a list of numbers. That follows a particular pattern. That's kind of a straightforward definition, okay? A series is actually when you have a sequence and you begin to add up those numbers, okay? So a series is when you have a sequence and you add them up.
Yeah, I remember.
So sigma notation is a way to write sequence in a, let's say, a shortened format. It doesn't look very nice. Quite often when students see this, they're like, it just looks a mess. I don't understand what it means. But it's actually, as long as you kind of think what every little bit in the sigma notation means, then you shouldn't have any problems. So, for example, an example of sigma notation. And I'll explain all this as we go. So this is sigma. Have you seen that symbol before? And what we say is sigma means the sum of, and we're going to sum from r equals 1, and we're going to take the value of r, we're going to substitute it into our little formula here, and we're going to go all the way up to, let's say, whatever number we want. Let's say 10. So this is a sequence. Let me just write in a few little bits of information. So sigma means the sum of. We start at this value, r equals 1, and you end at r equals 10, okay? And you go by integer values. What's an integer?
A whole number.
Good. Does that include negative numbers?
Yes.
Good. All right, so if I was to expand this sequence, all we have to do is we start off at r is equal to 1, and we substitute it into our formula. So if I take r is equal to 1 and substitute it into this, what's the first number I get out?
3.
3. Okay, what is the next number I get out?
5.
Because I put in r is equal to 2. Yep, 2 2s are 4, add 1 is 5. What is the next one?
7.
What's the next one?
9.
9, yep. And if I put a few dots here, dot, 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 what's the last one going to be?
Isn't it end at 10?
Yep. 21, because I put 10 into it.
Oh, so it means end at r is 10.
Yeah.
Not,
Yeah.
Okay.
Yep, okay, let me clarify that. And here, r equals 10. So, 21, and that is the full, this is actually a series or a sequence, okay? Does that make sense?
Yes.
It's not particularly very difficult, yeah?
Yeah.
But a lot of students, when they see something like this, it freaks them out. Could I take this, now I'm going to use sequence and series interchangeably, okay? Technically, a series is a sequence that is added up, but I'm just going to use it interchangeably. And we'll talk about series as well, don't worry. Could I rewrite this sequence a different way using sigma notation? So say starting at a particular value, let's 3, I want exactly the same output, but I want to see, can I pick a different formula, a different starting value, and a different end value? What time does this class finish at? Okay.
Okay, this one may
Yep.
seem
Let's try it.
so 3r minus minus r minus 1. If that in brackets, sorry, in brackets, minus bracket r minus 1.
So that's really 2r minus 1.
Oh.
Because 3r minus r, that's 2r plus 1 actually.
Okay.
Okay,
Well,
but if you want
it's
to,
technically different kind of.
it's the same thing.
I guess, yeah.
But what I mean is like something completely different.
Yeah, okay.
Maybe start with the starting. We started with r is equal to 1, didn't we?
Oh, so we can change that.
Yeah, we can change any of this we want. Okay, so let's start with r is equal to 0. So if r is equal to 0, how is this going to look? How is our formula going to look? So tell me what you think, Ashlyn.
So it would be like 2y.
Right.
2y plus 3.
Okay, well that makes sense when r is 0. When r is 1 though, 2 1s are 2, plus 3 is 5. That works. When r is 3, 3 2s are 6, 7, 8, sorry, when r is, yeah, 3 2s are 6, 7, 8, 9. I get 9 out, 2 2s are 4, 5, 6, 7. That works. Yeah, when r is 2, 2 2s are 4, 5, 6, 7. So this is r is 0, r is 1, r is 2, r is 3. So we're getting exactly the same sequence out. Now what does this have to go up to? to 9. Let's check. 2 9s are 18.
Yeah.
18 plus 3 is 21. So you can see that these two sequences are exactly the same thing, okay? This sigma notation and this sigma notation are exactly the same, okay? You don't always have to start at 1. You could start at 0, you could start at -1, you could start at 5, it doesn't matter, okay? But the important thing is to realize that you can get exactly the same sequence out, okay? Make sense? Okay, have a go at this for me. Write out the first four terms, last term, of the series. Okay, have a go at those. And have a go at this. And Nick, when you're doing this at home, pause this, have a go at it. Everyone? What do you got, Ashlyn? Yep. Yep, and then the last one was what, sorry? Yeah, 90, okay, good. Everybody get that okay?
Yeah.
Good. And remember you have to put, did we all put the little pluses?
Yeah.
Yep. Okay, good. Good. Remember, it's sigma means sum of, okay, so you are summing these things up. On part B, are we doing fractions or are we doing decimals?
I did fractions.
Good.
Okay.
What's the first term for part B, Zoe? So put 1 in, we get 1 plus 1 is 2 on the top. And then 2 1s are 2, 2 take away 1, yep. What's the next term, Greg?
1.
So it's 3, sorry. Yeah, 3 over 4 minus 1. Yes, good. The next term, Ashlyn. Yep, 4/5. Did we get that?
Yeah.
And the next one, 5 over 5, 4 2s are 8. 8 minus 1 is 7. Correct?
Huh? Yes.
And the last one would be 9 over 15. Okay, good. We all get that okay?
Yeah.
Okay, good. And of course, you could get different answers for these depending on your starting point. If you start at 1, that's absolutely fine. If you start at 0, it's fine. If you start at -100, that's fine for R. It's up to you what you want to start at, as long as it works. If you want to try and be smart, you can start at a really awkward value, like -3043. And then that means I'll just have to sit and work it out.
I saw a question like this before on the internet
Mm-hmm.
for B. Like it was something like that. They did some sort of experiment apparently. And they got a bunch of people to say what the answer to that is. And like half said, 1, and then the other half said 0.
Oh, right, okay, yeah.
And then like and it didn't get to the end of it, so I don't know what the answer actually did be.
You can actually. You can't. Back that. That's a good point. Has anybody got an answer for part A here?
Yes.
Go for it, Ashlyn.
Well, R equals 0,
Okay.
and then 8R plus 3.
Say again. 8R.
Plus
8R plus 3, and you went up to.
4.
You went up to 4. Okay, so that makes sense because 0, 1, 2, 3, 4 will give you 5 values. Let's just check a couple. 8 times nothing is nothing, plus 3 is 3. Let's try the last one. 4 8s are 32, plus 3 is 35. Good. Okay, did anybody do anything different? You all started at 0?
Yeah.
Zoe?
I got
8R minus 5.
starting at
Okay. Now, if you do get anything different, just let me know, because it doesn't necessarily mean that you're wrong or anything like that. 8 1s are 8. 8 minus 5 is 3. Good. 8 2s are 16. 16 minus 5 is 11. What did you go up to, Zoe? 5. Good. You got 1, 2, 3, 4, 5 values. 5 8s are 40. 40 minus 5 is 35. Good. Okay, so both of those are spot on. This one, slightly trickier. Has anybody got an answer for it? Okay, so a bit of a clue is, how do you make a number go to, say I've got the number,
I think I got it.
if I've got the number -1, how do I make that positive or negative?
I don't know the name is. I forgot. Absolute value?
No absolute value?
Wow.
Well, yeah, the absolute value will make it always positive, but then how do I need it to alternate, so go from positive to negative to positive to negative.
Power of
Powers, right. Yeah, so if this is positive, sorry, not positive, if it's, say, 2, that's going to give me 1 out. If it's 3, it's going to give me -1 out. Correct?
yes.
If it's 4, it's going to give me positive out again, okay? So let's see if you can figure out using that info.
I think I have one.
Okay, go for it. We're running out of time.
So sigma sign.
Yep.
Start at r equals 2.
Okay.
And then bracket -1
Yep.
to the power of r.
Right, okay, good, that'll work. And what are you going up to? Because this has
I
got
don't know,
dot, dot,
this
dot.
is dot, 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 infinity.
Infinity, right, okay. That means it keeps going forever and ever. Okay, good. Does that make sense? The first one is we put r is equal to 2, that gives us positive 1 out. And r is 3 then, next, we get negative 1 out, and so on. If I wanted to start it, sorry, I know we're running out of time, but I just love this stuff. At r equals 1, how's that going to change it? Not 2r,
R
r,
plus 1.
r plus 1.
Or
So the first one would be, yeah, that's right. Yeah, good. You put r is equal to 1, that gives you 2 out, r squared, positive, and so on, okay? So different ways you could do it. Make sense?
yes.
All happy?
Yes.
We're not panicking just yet?
Not yet.
All right, good. I will see you later on this afternoon.